willpower is not advantageous. Hence the example I gave earlier about eating disorders, where an apparently hardwired function of our brain to be able to generate some sort of reward for resisting a given behavior goes too far and then can actually threaten one's own health or even life. So the concept of allostatic load, allostatic balance, and allostatic function is something that we get into in a fair amount of detail in the discussion with Dr. Feldman-Barrett in that episode, which is coming out soon. But in the meantime, if you are to think about the anterior mid-cingulate cortex as having a single function, the function that Dr. Feldman-Barrett has ascribed to it as controlling how much energy different brain and body areas should get in a given context, well, that makes a lot of sense to me, and I think it's the one that best describes all of the functional data, indeed includes or jives with all the anatomical data about the anterior mid-cingulate cortex as well. One of the really important twists in all of this is that the anterior mid-cingulate cortex is not just sitting there to allocate and dole out different amounts of energy and activation to different brain areas. It is also receiving input from both the brain and body. And in sort of a beautiful twist on the whole story of what the anterior mid-cingulate cortex does, we know that when we move our body, we are activating the anterior mid-cingulate cortex. And we know that when we move our body, because we in some way forced ourselves or encouraged ourselves to do it, we activate the anterior mid-cingulate cortex more. Similarly, and because the anterior mid-cingulate cortex is so flexible in the different contexts in which it can be activated, if we are simply reading, or we are listening to something that we're supposed to learn, or trying to learn a piece of music, or trying to do anything for that matter, the anterior mid-cingulate cortex, yes, will be activated, but that its levels of activation are far greater when we experience a lot of resistance that we have to overcome. Remember the earlier results, and by the way, I'll provide a link in the show note captions to this particular study or set of studies. There are about two, one really spectacular one and a couple of others that tangentially point to the same finding, that when people engage in a hard task, not an easy task, but a hard task, that the anterior mid-cingulate cortex activity is elevated. So the way to think about the anterior mid-cingulate cortex is that it's not just sitting there as a hub that you have to reach into and activate. It's also receiving inputs that can activate it. And that's what allows us to now talk about the tools and protocols that don't just allow us to engage our anterior mid-cingulate cortex and access more tenacity and willpower, but that allow us to exercise, not necessarily in the context of physical exercise, although it could be that too, but to exercise our anterior mid-cingulate cortice's ability to engage not just in that challenging context, but in other challenging contexts as well. In fact, I'll just tell you right now that studies in non-human primates, and to a limited extent in humans, but here we think there's a strong analog between the non-human primate data and the human data, the anterior mid-cingulate cortex is chock-a-block full of the expression of molecules such as chem kinase 2, receptors to various neurotrophins, particular types of NMDA and methyl D-aspartate receptors, all of which, if none of those names mean anything to you, just know that all of them refer to different aspects of and a capacity for synaptic plasticity, which is the ability for connections in the brain to change. They can get stronger, you can actually grow new connections. In other words, the anterior mid-cingulate cortex can be built up as a structure to engage tenacity and willpower by activating it through one or a limited number of different types of behaviors, meaning engagement in behaviors that, frankly, we would rather not engage in, as well as not engaging in behaviors that reflexively we really want to, that we're sort of drawn to engage in. Both of those contexts, the I absolutely will, even though, frankly, I don't want to, or you're telling me I can't, as well as the I absolutely won't, even though you're tempting me to do that, or that's tempting me to do that, or even I'm tempted to do that. That buildup of the anterior mid-cingulate cortex has extensive carryover into other domains of life because it's the same structure that is then used for other types of behaviors and learning that require tenacity and willpower. So that's incredibly reassuring. In fact, it's downright exciting because, as I mentioned earlier, while there are a near infinite number of different circumstances where we each and all need tenacity and willpower, it seems that there's a very generic mechanism for generating tenacity and willpower. And that means that if we can build up our capacity for tenacity and willpower by engaging in particular types of behaviors and resisting particular types of behaviors, well, then it's going to carry over in a very functional way to the other aspects of life that we find challenging and that we may find challenging in the future. Okay, so by now, I like to think that I've convinced you, because frankly, the data are very convincing, that the anterior mid-cingulate cortex is a vital hub within your brain for allocating energy and resources to generating tenacity and willpower. And perhaps it's taken you a lot of tenacity and willpower to get this far through the episode, waiting with bated breath, presumably, to learn how exactly you can improve the functioning of your anterior mid-cingulate cortex. Now, fortunately, there are published peer-reviewed data that explain how to do that. In fact, there's a study that was published in 2006 by Colom and colleagues entitled Aerobic Exercise Training Increases Brain Volume in Aging Humans. And before you go run off, literally, and engage in cardiovascular exercise, I'm just going to describe to you the contour of this study and what specifically was done so that you can best implement the best protocols for your particular circumstances. This was a study exploring why and how certain brain areas and brain volume generally decreases as we age. It's well known, as I mentioned earlier, that individuals aged really 50 and older, and maybe as early as 30 and older, experience a decrease in brain volume, with particular brain areas shrinking faster than others. But of course, there are other people that include the superagers that we talked about earlier, and many, many other people who are not superagers who don't experience the same decrease in brain volume. So why is it that they maintain the same brain size that they did when they were younger, or undergo less decrease in brain size? That's what the researchers for the study were initially interested in understanding. And they did come to some really interesting conclusions about that, but they also came to some interesting conclusions that relate to today's discussion on tenacity and willpower. This study involved having individuals who were 60 to 79 years old divided into one of two groups. One group did cardiovascular exercise. The other group did more calisthenics/stretching type exercise. Both groups did 1 hour of exercise 3 times per week. The group that did cardiovascular training initially started off by doing, and by the way, they just simply called it aerobic training, but this could be rowing on the rower, this could be running, this could be cycling. I think for sake of understanding application of tools and protocols, you would want to pick any kind of activity that you could do consistently without injuring yourself. That's what's really important, and that gets your heart rate elevated. They started off, these individuals, with relatively low intensity cardiovascular exercise for that hour, getting their heart rate up to about 50% of their maximum heart rate, but very quickly had those individuals increase the intensity of those cardiovascular training sessions. So they were doing, again, 3 1-hour sessions per week, getting their heart rate up to about 75% of their maximum heart rate. Sometimes a little less, 60%, sometimes a little bit more, but in that general range. So for those of you that think about different zones of cardio, this is probably in the area of zone 3, not quite zone 2 cardio, maybe zone 3 cardio, so where one can not carry out a conversation very easily, but where one is not completely gasping for air as one would if they went to their maximum heart rate or near maximum heart rate. Okay, so 3 1-hour episodes of cardiovascular training per week at a moderately high intensity. The other group simply doing calisthenics and stretching for the equivalent amount of time. And they had another group within the study that were much younger that did similar activities or no activity simply as a control for the brain imaging data. Now, I'm summarizing the study with a fairly broad brush, both for sake of time, and of course I'll provide a link to the study in the show note caption so you can access it and peruse it in more detail if you like. But I wouldn't be talking about this study if it were simply a study about cardiovascular training and brain volume. I'm talking about this study because the specific brain areas that maintained or in some cases increased in volume as a consequence of doing these 3 hours per week of moderate intensity cardiovascular training included, of course, the anterior mid-cingulate cortex. That was actually the primary location in which the maintenance of brain volume was observed, and in some cases, increases in brain volume were observed, right? This is a group of people who normally would be losing volume, size of their anterior mid-cingulate cortex, but for which 3 hours a week of moderate intensity cardiovascular training maintained the volume, the size of that anterior mid-cingulate cortex, and in some cases increased the volume, the size of anterior mid-cingulate cortex. And they also observed a maintenance or increase in the size of the anterior white matter tracts. Remember, TRACTS? I didn't spell that out before just to spell it out for fun, although that is the sort of thing that I would probably do. Those white matter tracts are the communication routes by which different brain areas communicate, and this anterior white matter tract that maintained size in the people that did cardiovascular training as compared to those that simply did the calisthenics training and stretching is the very white matter tracts that connects the two sides of the brain, the frontal lobes, that allows the anterior mid-cingulate cortex on one side of the brain and the anterior mid-cingulate cortex on the other side of the brain, as well as other brain structures, to communicate with one another. So this is really spectacular. I mean, the authors of the study didn't embark on the study to find or even look for increases or maintenance in the volume of the anterior mid-cingulate cortex and the communication routes in and out of the anterior mid-cingulate cortex. It just so happened that cardiovascular training done 3 times per week for an hour at a time at moderate intensity increased the size of the anterior mid-cingulate cortex. And as I mentioned, the white matter tracts, which allow information to go in and out of the anterior mid-cingulate cortex. Now, we should all be asking ourselves, why would that be the case? I mean, somebody gets on a stationary bike and pedals or goes out on a road bike or runs. Is there something inherent to running or cycling or rowing or swimming or an aerobics class, dancing, etc., that gets the heart rate up, that directly feeds into the anterior mid-cingulate cortex? After all, is the anterior mid-cingulate cortex responsible for generating the activity of running or cycling or swimming? No. Rather, the interpretation is that in order to engage in this 1 hour, 3 times per week set of sessions of cardiovascular training, they had to allocate resources. They had to get up out of a chair. They had to get off the couch. They had to say no to other potential obligations, social engagements, meals, etc., and get to these exercise classes or sessions that they did with others or alone. Now, an interesting and, in fact, important aspect of the study is that the compliance with this 3 hours per week of cardiovascular training was very high. 85% of individuals engaged in these sessions across the 6-month period of the study. I should have mentioned that earlier. The study was carried out over the course of 6 months. They did not have the opportunity to do neuroimaging after, say, a week or 2 weeks. So they imaged these people's brains before and they imaged these people's brains after this 6-month period. It's anybody's guess as to whether or not they would have observed the same or maybe even greater increases at the 1-month interval, etc. We simply don't know. There's a great cost, both energetic and financial, to doing these kinds of studies. So they looked at a 6-month period. But setting all of that aside, this is a very important study in the context of today's discussion, because what it means is that if we acknowledge that the anterior mid-cingulate cortex